All right, now that we've seen the important features of a sampling distribution, let's jump into an example. So the average height of an American male is 70 inches with a standard deviation of 3 inches. If we take a sample of 36 men, what is the probability that their mean height is more than 72 inches? So what I'm going to do with this problem is I'm going to start by underlining any piece of helpful information or highlighting. I'm going to highlight actually. So the average, maybe I'm not going to highlight. That's a really big highlighter. Can I make that smaller? Yes, I can. So the average height, also known as the mean, is 70 inches. And the standard deviation is 3 inches. We are sampling 36 men. We're being asked to find what is the probability that their mean height is more than 72 inches. So I've got a lot of numbers here. So another thing I'm going to go ahead and take a moment to do is I'm going to write down each number that I have highlighted. And I'm going to identify what symbol that number is represented by. So a sample of 36 men, that's my sample size, that's N. And then this 72 is the mean of the sample of 36 men. So this is 72, this is the mean from the sample. So that must be X bar. And then the average height of an American male, that's looking at all American males. So this is the average or the mean for all American males. So that's going to be mu, the mean for the population. And then this standard deviation is also for all of the American males. So that's going to be sigma. I identified them in this order. You could identify them in any order. So now, let's see. I have mu, sigma, n, and x bar, and I'm being asked to find a probability. So the first thing that I'm going to want to check is, do I have a normal distribution? If I don't have a normal distribution, I can't find this probability. So in order for this to be normally distributed, I need to either see somewhere in the problem that the population is normal, or I need to have a sample size of 30 or more. So in this case, my sample size is 36, which is in fact more than 30. So I do have a normal distribution, which means I can follow the same 4-step process that I did when I was looking for the probability of an individual from a normal population. So the first step in that process was to find the z-score. So now the z-score for a sampling distribution where we're looking for the probability that a mean score varies from a population mean is x bar minus mu divided by sigma over the square root of n. So now by taking a moment to identify each of the values, I can go ahead and just plug everything in. So 72 minus 70 divided by 3 over the square root of 36. Want to make sure when we're doing this that we do the top and bottom separately. If you have repeating decimals, do not round those until you get to the very end. Very, very end of your z-score. So 72 minus 70 is 2. The square root of 36, this die becomes 6. 3 divided by 6 is 0.5. 2 divided by 0.5 is 4. This was a little bit bigger than I think I intended for it to be, but that's okay. So our z-score is 4. If you take 36 men, and they have an average height of 72 inches, they would be 4 standard deviations above the mean. So we're going to draw that. Step 2. Make sure you're always doing this. Draw your curve. Okay, we now have this in terms of z-scores. So the z-score of the mean is always 0. And then I'm going to label the z-score for my specific values that I found. And then step 3 is to shade our curve. So step 2 is to draw the curve. So we want to know what is the probability that it is more than 72. So I'm going to shade more than 4. And then the last step is to find the probability using Excel. So the name of the function in Excel, always start with an equal sign, norm.dist, my computer won't wake up, there we go. Whoopsies. Norm.dist, nope, I'm sorry. Norm.s.dist. Because then we only have to type in 2 things. We're going to enter the z-score of 4, and then we're going to enter true because we want a cumulative probability, not just an individual probability. So I'm going to type in 4, comma, true. And that's going to give me 0.99996833. But remember, one of the things about this function in Excel is that Excel assumes you want the area to the left, not the area to the right, which is what we want. So to find the area to the right, we need to take 1 minus what we got from Excel. So when we do that, 1 minus 0.99996833, it is a very small probability So if you were to round this to 4 decimals, the answer would be 0. But when we look at this example, what we just did here, so we have a sampling distribution. We're taking a sample of 36 people and we're looking at what is the probability that their mean height is more than 72 compared to what we were doing before where we were looking at, I'm just picking out one person from the population, an individual person. When we actually get into the process of calculating this probability, the only part of that process that changed was the first step. I have a different formula to calculate the z-score. But once I have a z-score is a z-score. It's giving me a distance from the mean in terms of the standard deviation. So it doesn't change what I do in steps 2, 3, and 4 compared to what we were doing before when we were looking at that individual. So here is our example of how to find a probability if we have a sample of more than one person from a population.